This lesson is about the angles of a polygon. This is section 3-5 in your textbook. The essential question for this lesson is, what is a polygon, and what do we know about the interior and exterior angles of a convex polygon? So what is a polygon? A polygon basically is a multi-sided closed figure. Okay, it's composed of straight sides. It is a closed figure, and that's pretty much it. Now here are some pictures of different types of polygons. Notice the top row are convex polygons, while as the next row are concave polygons. And you'll notice what the difference is, that the sides actually cut in, and we have it going into the polygon on the concave. We're going to primarily deal with convex polygons, which is the top row. Then the bottom row, we show examples that are not polygons, either that they're not closed, that segments are crossing. Not all sides are line segments. You can't have a curved side for it to be in a polygon, or if it's not all in one plane. So this pretty much describes what we mean by polygons. In this section, we're going to have two theorems relating to the angles of a polygon. The first is Theorem 313, and this deals with the interior angles of a polygon. And this theorem simply states that the sum of the measures of the angles of a convex polygon with n sides is n minus 2 times 180. So let's see how this works. Let me draw a four-sided polygon to begin with, okay? And this isn't going to be real accurate, but... So I've got a four-sided polygon right there. Now, if I wanted, I could divide this into triangles, and this four-sided polygon can be divided into two triangles. Well, the sum of the angles of a triangle is 180. Well, I've got two triangles here, so obviously the sum of the interior angles here is going to be 2 times 180. Okay? And what is 2? 2 is 2 less than the number of sides, because we have 4 sides, so 4 minus 2 is 2, so 2 times 180 is the sum of the interior angles. All right, well now let's look at more sides to the figure. Let's say we got 1, 2, 3, 4, 5 sides, okay? So we got basically a pentagon. And again, I'm going to divide this up into triangles. So we got one triangle, two triangles. So now we got 3 triangles. So the sum of the interior angles would be 3 times 180. And again, notice that 3 is 2 less than the number of sides we had, which was 5. So let's do one more figure. Let's do a hexagon. So let's see, 1, 2, and gotta get that straight there. 3, 4, 5, 6. Okay. Now, if we've got a hexagon, how many triangles can we divide it into? We can divide it into 1, 2, 3, 4 triangles. So our answer is 4 times 180. And again, 4 is 2 less than the number of sides, which was 6, since this was a hexagon. So that explains how we came up with this theorem, Theorem 3-13, that the sum of the measures of the angles of a convex polygon with n sides is n minus 2 times 180. Now we're going to discuss our other theorem in this section, and that is Theorem 3-14. Well, 3-13 dealt with interior angles, so it's probably pretty obvious that 3-14 is probably going to deal with exterior angles. And this theorem simply states that the sum of the measures of the exterior angles of any convex polygon with one angle at each vertex is 360. So it doesn't matter how many sides your polygon has, the sum of the exterior angles is always going to be 360. Now you might recall when we were talking about triangles, we showed how with a triangle the sum of the exterior angles is 360. Well, this same rule holds for any polygon, no matter how many sides you've got. So let's look at this theorem and how we might understand it better. For now, I'm going to use as examples regular polygons. In other words, all the sides are going to be equal. So I'm going to start off with a square. So let's draw my square. It's going to look something like this. Not a perfect square, but I think you'll get the idea. Now, the interior angles are all 90 degrees. So the sum of the interior angles is obviously going to be, because we got 4 sides, so the sum of the interior angles is going to be 4 minus 2 times 180, which obviously comes out to be 360. We got 4 angles, so each angle is a right angle. So we've got 4 right angles here, okay? We've got a right angle there, right angle there, right angle there, and one here. Now, obviously, each exterior angle is also going to be 90 degrees. So we've got 4 of them, so it's 4 times 90. So the sum of the exterior angles in this case is obviously 360. All right, let's look at a different figure. Let's look at a hexagon, okay? And this is going to be a regular hexagon. So we got one side, 2, 3, 4, 5, 6. All right, now the sum of the interior angles is obviously going to be 6 minus 2 times 180. So this is 6 minus 2 times 180. Okay, so that's going to be 4 times 180, or 720. Now, if the sum of the interior angles is 720, and all interior angles are equal, that means that each interior angle is going to be 720 divided by 6, or 120. So each interior angle is 120, which means each exterior angle is going to be 60. But how many of them do we have? We've got 6 of them. So we say 6 times 60, and what does it become? Lo and behold, 360. So we know it's 360 for a triangle because we proved it in class. We know it's 360 for a square. We know it's 360 for a hexagon. So it's not too much of a stretch to realize that it's going to be 360 regardless of the number of sides you have. Now I would like you to find the measures of each interior and exterior angle of a regular octagon and post your answers in the drop box. Remember, if it's a regular figure, that means all the sides are equal, and in this case we're talking an octagon, so that means there's 8 sides.